Here's the graph of square root of x, and we want to graph y minus 2 equals negative square root of 3x plus 3. The first thing I'm going to do is I'm going to move that 2 over, and I'm just not going to write the inside first, because I want to look at that and say, well, what does everything do? What does that negative do? Vertical or horizontal? X or y? First negative. That's going to affect y. It's going to reflect it over the x-axis. The 3 here is going to be what? Okay, but what is that 3 going to do? We're not going to say exactly what number, but is it vertical or horizontal? Horizontal. Stretch, compression, or translation? Compression. And this 3, horizontal or vertical? Horizontal. Stretch, compression, or translation? Translation. And so this question has the special note that we wrote down the other day come into effect. And that special note was whenever we have a horizontal stretch, horizontal compression, or horizontal reflection, along with a horizontal translation, exactly what we have here, those two things happening at the same time, you have to write it in factored form. And right now, it's not in factored form. So we factor the 3 out, leaving us with x plus 1. So our gut feeling when we see this is that this graph is moving 3 to the left. But in reality, it's only going to be moving 1 to the left. So now that we have this, we can list what each of these things is going to do. This is going to multiply y by negative 1. The 3 is going to multiply x by 1/3. We just talked about this. 1 is actually 1 to the left. And the 2 will be up 2. Now, if we're looking at specific points that we can transform using these transformations, we're for sure going to use 0, 0, because that's the starting point of this square root graph that continues on forever that way. And so we need to know the starting point of our graph after the transformations. And then we always did our stretches and compressions first, got new points, and then we'll do our translations next and find our new points. Now, what other points we choose is up to us. However, some points, since we've listed a shortcut of what's going to happen, some points that we're going to choose are going to cause us to have fractions. Okay? One of those points, if you chose 1, 1, my final point after the transformations is going to have fractions. How do I know that? Because I'm multiplying x by 1/3. So this will cause me to have fractions. And that's okay. I'm going to do that point with fractions. However, when you're doing a question like this, if you can think of points that avoid fractions, it often makes your mental math easier. So can you tell me a point on the red graph that would avoid fractions? 9 and 3. Because when we multiply that x by 1/3, it'll work out to a nice whole number. So I'm going to list my transformations above here. We're going to multiply y by negative 1, x by 1/3, and my translations here, 1 to the left, 2 up. And let's see where these points go. Well, 0, 0 multiplying will stay 0, 0. 1, 1, when I multiply this will become the fraction, 1/3. And 1 times by negative 1 will become negative 1. And 9, 3, when I multiply by 1/3, this will become 3. And multiply by the negative 1, this will become negative 3. So we see in that last point we still have whole numbers, but in our second point we have some fractions. Moving 1 to the left and 2 up, So this will become -1 comma 2. Moving 1 to the left, how do we move 1 to the left from 1/3? What are we going to do? We have to subtract 1. How do you add and subtract fractions? Get a common denominator, so that 1 will be 3/3, and you will get -2/3. Going up to, this will become +1. And 3 and -3, 1 to the left will be a 2, 2 up, we'll get this to -1. So if we plot those points on the same graph, -1 comma 2, notice that your x's are going by 2, so -1 is only half here. -1 comma 2 would be right there. -2/3 comma 1, it's harder to graph because you're dealing with fractions. So if this is 1 halfway in between there, you'd have to estimate 2/3, -2/3 would be a part of the way there, comma 1 would be approximately there. But you can see why the whole numbers are nicer to work with. So when we go to graph 2, -1, we end up with this point. Now, on your exam, they're not only going to look that you've got points labeled correctly or that you've figured out where your points are supposed to be, they also want the shape of your final graph to be the right shape. So when you draw these 3 points, there's a number of different options. So I'm going to draw, don't draw these ones right now. I'm going to draw some that are right, some that are wrong. I'm going to just join these with a line. I'm going to curve it. Oh, this one's curved, so I'm going to curve it down. Or maybe I think, oh, maybe it was supposed to curve this way. So what shape is the right shape? Okay? And in order to do that, what is a good plan to do is to think about these things. If we walk through these things, what does y by -1 do? It flips it over the x. That would start by flipping it down like that. That's my shape. What does x by 1/3 do? Compresses it. So now it's still that shape, but squished that way. 1 to the left and 2 up. So that's the shape that I need to have for my final graph. It needs to start at this point and curve that way. And you can mainly see that by the negative. Because the negative flips it down, you can see what the shape would be if it was flipped down, and then you know what the shape of your final graph needs to look like. This question just says, what is the domain and range of the final graph? The domain, what's the smallest x value? Smallest x value is -1. The domain is everything bigger than or equal to -1. And the range, it has no smallest value, but it has a biggest value at 2. Y is less than or equal to 2. Questions you can work on, and we're going to practice some of those right now, are 8 and 10.